Hello everyone, welcome back to the channel Infinity by Yashaswini. Imagine you have rupees 100 and you want to share it equally among three friends. Each person get rupees 33.333333. But where does this endless decimal come from? Is it a number? Can every number be written as a fraction? Today, we will discover a fascinating world of numbers and find the answers. Today, we are starting one of the most important chapters in class 10th mathematics, that is real numbers. This chapter is very important for board examination, competitive exams, and higher mathematics. In this chapter, we are learning introduction and number system review, Euclid's division lemma, Euclid's division algorithm, fundamental theorem of arithmetic, irrational numbers, rational numbers and decimal expansions, practice problems, JEE and IIT level questions, important theorems and proofs, and summary and key formulas. In this video, we will understand natural numbers, whole numbers, integers, rational numbers, irrational numbers, mind map of real numbers, and practice problems. By the end of this video, you will understand how numbers evolved from counting objects to describing endless decimals and irrational values. Look around your room and identify different numbers. For example, you can find 5 books, and the room temperature may be 32 degrees Celsius. Height of the door will be like 2.1 meter. Money in your wallet is rupees 250. Distance to your school may be 3.5 kilometers. Are all these numbers are of the same type? Let's find out. All numbers are real numbers. Mathematicians divided numbers into different categories. The first category is rational numbers, and another category is irrational numbers. A rational number is again categorized as integers and fractions. Integers again categorized as whole number and negative integers. Whole numbers again categorized as natural numbers and zero. Let's understand one by one. The first one is natural numbers. Natural numbers are the first numbers humans used for counting, and you all know that 1, 2, 3, 4, 5, etc. are counting numbers. And natural numbers are denoted by the letter n. We use natural numbers for counting students, counting apples, counting cars, etc. So these are basically a counting numbers. Then we have whole numbers. What if there are no apples? To represent nothing, mathematician introduced zero. So 0, 1, 2, 3, 4, etc. forms a whole numbers. Means all the natural numbers along with 0 forms an whole numbers, and whole numbers are represented by the letter W. Then comes integers. Suppose Bangalore temperature is 25 degrees Celsius, Antarctica temperature is minus 10 degrees Celsius. How do we represent values below 0? So these are called as integers. So integers includes all the positive numbers, negative numbers along with 0, and integers are represented by the letter Z. For example, bank balance, elevators, temperatures, profit and loss. Now consider half of a pizza, that is 1 by 2, then 3/4 of a cake. These are fractions. Number that can be represented by P by Q are considered as rational numbers. For example, 1 by 2. You can take it as even negative fractions. Then 7. You can say 7 is not in the form of P by Q. 7 can be represented as 7 by 1. It is in the form of P by Q. 0, even 0 is a rational number. So 0 by 1. Rational numbers are in the form of p by q, where p and q belongs to integers. Q should not be equal to 0, be a 0. For example, if it comes like 7 by 0, it is not considered as a rational number. Denominator should not contain 0. You should keep in mind even decimals are belongs to rational numbers. For example, 0.5 can be written as 1 by 2, so it is an another form of rational numbers. Even 0.33333, you should remember that a decimal that terminates or repeats is always a rational number. Then another category is irrational numbers. Now let us discuss irrational numbers. Some numbers cannot be written as a fraction. For example, root 2, root 3, pi. These cannot be written as a fractions. Suppose a square has side length 1 unit, then using Pythagoras theorem, that is a square plus b square is equal to c square, the diagonal will become what? Root 2. The root 2 decimal value is 1.41421356. The digit never stop and never repeats. So these numbers are called as irrational numbers. So we can conclude that the irrational numbers cannot be written in fraction form and have non-terminating and non-repeating decimals. Examples: root 2, root 3, and pi. Engineers use root 2 in construction, architects use irrational numbers in designs, pi is used to calculate area and circumference of the circles. Scientists use irrational numbers in measurements. These are the real life applications of irrational numbers. Why root 2, root 3, and pi are irrational means you can observe that the digits are non repeating and non terminating. That's why these are irrational. So, non repeating and non terminating decimals which are having, those are called as irrational numbers. So we can say that all numbers are real numbers and real numbers are categorized as rational numbers and irrational numbers. This is a complete mind map of real numbers. So if you go from the base, the natural numbers along with zero forms on whole numbers, then whole numbers along with negative numbers forms integers, then all integers which are in the form of p by q and where q is not equal to 0 or rational numbers. Even terminating and recurring decimals are also considered as a rational numbers, and real numbers, all rational numbers and irrational numbers are considered as real numbers. Now pause the video and decide whether the following are rational or irrational. Root 7 by 8 is rational because it is in the form of p by q and q is not equal to 0. Root 11 is an irrational number. Then 0.272727 is a rational because the digits are repeating. Now for the fourth question, answer is irrational. Even the digits looks like repeating. See, you can see here 1 after only 1 zero is there, but here 2 zeros and here 3 zeros and here 4 zeros. So it is not like recurring. That's why it is an irrational. Pi is an irrational. Why? Because pi value, as we told, it is never ending and non-recurring or non-repeating. That's why pi is irrational number. Then root 4 is rational. Why? Because root 4 value is 2. So we can write root 4 as root 2 square and square root get cancelled. So 2 is the answer. It is a perfect square. That's why it is a rational number. See, this is a number line. Every point on the number line represent a real number, whether it may be an integers, whole numbers, natural numbers, irrational numbers or rational numbers. These all numbers represents a real numbers. Therefore, real numbers are all numbers that can be represented on a number line. Now I'll ask you few questions. Is 0 a natural number? Is every integer a rational number? And classify -12, -7, 3 by 7, root 7 as natural numbers, whole numbers, integers, or irrational numbers. Answer your comment below. So today we'll learn different types of numbers and understood that every rational number can be written as a fraction. But have you ever wondered how mathematicians find the highest common factor of very large numbers? For example, how would you find the HCF of 867 and 255 without listing all factors? More than 2300 years ago, a Greek mathematician named Euclid discovered a brilliant method to solve this problem. In our next video, we will learn the powerful concept of Euclid's division lemma, which forms the foundation for finding HCF efficiently. Until then, try identifying rational and irrational numbers around you and share your answer in the comments. Don't forget to like, share, and subscribe for more exciting mathematics lessons. Thank you.